So guys, welcome back. This is me again. Let's resume our course. So in this class, this is the 8th class. So we are going to discuss about the fatigue and how you can analyze it, and you can take an account that this is very important for your bridge design and for a bridge engineer to know about the stresses caused by fatigue and its consequences to the whole bridge as a structure, whatever the material you choose, steel or pre-stressed concrete or reinforced concrete, whatever. You have to take into account these stresses over your bridge. So welcome to this class. Well, we have to know that fatigue can be broadly defined as a phenomenon of reduced material resistance under fluctuating stresses. It is related to loss of member strength under repeated loading. What is interesting about fatigue is the fact that failure can occur under well below the ultimate loads if a member is subject to a repetitive loading. Therefore, fatigue limit can be defined as the maximum stress that can be repeated indefinitely without causing fatigue failure when applying fluctuating loads. Fatigue was discovered during the development of railroads in Europe as a result of failures of the axles of railroad cars. The mechanism of fatigue failure is believed to begin at the surface of a member where there are microscopic imperfections which act as stress raisers. As a result, the stresses at this location become much greater than the average stress acting over the cross-section. So we have to pay attention to our workload. It's the same, all right? But you have to pay attention here. The distance between axles, loads are the same. 8 kips, 32 kips here, and 32 kips here in the rear axle. You can use this formula, okay, this equation, in order to find the fatigue. 72 times the point that you want to analyze divided by the overall length of the bridge, or the span, better saying the span here. L minus X minus 11.78 minus 112. If I analyze it at the point 36 feet, you can find these results. All right, so I put it also in our software. All right, this is taken out from the BridgeLink software. So you can see here at the point 36 feet, you can find these stresses caused by the fatigue. All right, the same as we calculated here using the equation, classical equation for finding fatigue over a bridge. But we can also use influence lines, as you can see here. I demonstrated for you guys here how to find it using influence lines equations. So I declared here the point where you can find the axles. Axle number 1 or the front axle of your truck. The load here 8 kips, the middle axle and the rear axle here. You can find by using these equations in order to find where it's located over the bridge. All right, the middle point of your bridge. So I put it down here, a graphical example of how to find the stresses. This is the point that we are analyzing. So what's the moment stresses at the midpoint here, the middle of our bridge, our span? Since it's a 3 spans bridge, you have to take care here, because we are this L or we are analyzing over one single span. All right, so the moment equation, you can use it. It's here. we chosen to analyze at the point 12 feet. So this is the fourth found. I can use it also the F2 software. So at the point 12 feet from the left port here, you can find this stress 743.2 kips. So what this is what we found using the equation. So it fits, it's all right, perfect. Or you can analyze it at any point. Let's see, at 24, I'm putting here 24. Let's see what happens. 24 moment here is 1288. All right, so fits perfectly, leaving it as 12. Oops. See here, can using these equations only until 28, so I can use it 36 here. Let's go back to 12 feet. All right, okay, I'm showing you here the results on the BridgeLink software. All right, 12 feet fits, 24 feet fits, right? These amounts here I have shown you in the previous section. And if you want to know how to find the equations of the influence lines, I demonstrated here for you. See what happens when the middle axle is at the point 48 feet from the left side of the bridge of the span. The same equations for finding what the axle is. So 48 here, you have to find 1865. This is what happens here. So I'm demonstrating you guys how to find it using both a equation or using a software. So how it works here in this amazing course for you. All right, I demonstrated here at 36 feet. Also demonstrate here how to find where are the axles of the truck, the load truck over your bridge. This was already calculated here. 36 at the F2 software. I can find this amount of moment, bending moment. It fits with the use of our equation here. So guys, this is amazing how finding these amounts of stresses, and you have to know how to calculate it so you can follow up this manual for finding the results. I demonstrated for you all of this approach. So I hope you have enjoyed this class. Hope see you again. See you next time.